Hello and welcome to this SAF Improvement Bite-Size session on the theory of constraints. In this video we're going to talk about what the theory of constraints is and give an example of it in use. The theory of constraints comes from a book called The Goal by a person called Goldratt. It's a great book which is written as a novel rather than a textbook which details the steps you should take to improve a process. The book is set in a factory with a production line, but the theory is easily applicable to healthcare. If you think of a production line for making a car, you probably think of lots of different stations, each making a different part of the car on a production line. Any process will be limited by its biggest constraint, or the bit that takes the longest. If you think of a car production line, if the longest bit to fit was the windscreen, and this took an hour, regardless of how fast you could do all the other bits of the car, the maximum number of cars you'll be able to get in an hour would be one car, as you have the constraint of putting the windscreens in. This constraint, or bottleneck, can be called the weakest link in the chain. What the theory of constraints does is give you a guide on the order to do things to improve the output of this bottleneck and so to increase the throughput of the system. So the first step of the theory of constraints is to find out what the bottleneck is. Sometimes this will be obvious, but in improvement work, we will sometimes map out a process and measure the time each step takes to find the biggest constraint or bottleneck. The next step is to exploit the constraint, or in normal language, make sure it's working as hard as it can. This is usually the first step as it is the cheapest, fastest and easiest thing to do. Thinking of the car example, it might be ensuring that the windscreen station is always manned and there is no idle time on that station. Once that step is completed, we move to step 3, which is tuning in other areas to the constraint. This means making sure there is a queue in front of the constraint so that it is never idle. i.e. in the car example, we would always make sure that there is a car waiting for its windscreen so there was no idle time for the machine. The next step, which is usually the most expensive, is to elevate the performance of the constraint, or basically spend money on it. This might be buying another windscreen machine, for example. The last step is to circle back to the start and do the process again. It might be that the same thing is still your biggest issue, but it's likely that you'll have a new weakest link in the chain to improve. Now we're going to see an example of when the theory of constraints was used in the first wave of the pandemic. During the first wave of the pandemic, one of the Improvement Hub staff was involved in the production of PPE at Royal Wolverhampton's NHS Trust. The team started making their own visors for clinical staff to use due to supply issues. The improvement team at Royal Wolverhampton assisted in setting up the production line and then used the theory of constraints to try and improve the output of the system. The first step was to map out the process and find the slowest bit. In making the masks, the team had to cut the elastic to size, cut holes for buttons, stick some sponge to a visor, move all the pieces into a press the elastic and the visor together, and then put the masks in a box to deliver them to the wards. The slowest point was the pressing of the buttons, as the job was quite fiddly and involved using a press which would hurt your fingers if you caught them in the mechanism, so people were very careful, quite rightly, when using the equipment. The next step was to exploit the constraint, the press in this example. The way we did this was to ensure that the person using the press had regular, covered breaks, so they were pressing as fast as possible. When they did this, production improved. However, there were still times when the press wasn't in action as they were waiting for materials. The next step was to tune in other areas to the constraint. What they did was split up the visor and elastic parts of the process so there was always a queue in front of the press and it would always be in use. This again improved production. The next step the team took was to ask local businesses for more presses. The team found that the local schools had these presses and were more than happy to share them whilst PPE was being made. This in essence doubled the production. Following this process, the team went from making 1,000 masks a day to making 5,000 masks a day in a shorter shift. If you would like more information on the theory of constraints and how to apply it in your area, please contact the Improvement Hub. Thank you for listening.